in topic 2, we start doing our translations. All right, so now these ones, we still have to figure out the amplitude and the period, but then we start adding phase shifts and vertical shifts. So first one, we've got a sine graph. You still find the amplitude the exact same way. That's the value that's out front. The period, you still find the exact same way. So for sine, it'd be 2 pi divided by 2 for this one. So that is pi. And then we have the new possible addition of a phase shift and or vertical shift. So phase shifts are pretty easy to spot. So if you have parentheses, you don't have parentheses here. Notice this is what it should look like if you do have a phase shift. You don't have that here. So there's no movement left or right. You do have a vertical shift though. A vertical shift is always spotted by seeing a constant that's completely by itself and not in parentheses. So this is 1, and then because it's plus 1, that would be 1 unit up. So with the shifts, taking the whole graph 1 unit up, that's going to move the midline up. Instead of y equals 0, it moves up 1, and it's now at y equals 1. All right, so the whole graph, and you don't have to do this, but I like to just kind of, even very faintly, draw in some sort of line. And it doesn't represent an asymptote. It just helps you to kind of just visually shift the whole graph up 1 unit. All right, so no phase shifts. So the cycle starts right on the y-axis, like it always does, and the sine starts what used to be the origin, but is now up at the value of the midline. Okay, so your sine graph is going to start right here. And then it finishes its cycle back on that midline. So pi units later, it's going to finish its cycle. So that's the end of the cycle. And then sine points 1 and 3 and 5 are on the midline. So here's the beginning, middle, and end of the cycle. We want to do the quarter points, as well. So a quarter of the way through, 3/4 of the way through. So a quarter of the way through, we go up to the high point. So that would be 3/2 of a unit up, or 1.5 unit up from the midline. Remember, no longer an actual value of 3/2, but it's 3/2 higher than wherever the midline is. And then 3/4 of the way through, it is 3/2 of a unit down. So that's one cycle. So you just take that and you perfectly repeat it. So you notice what the pattern looks like. Every 2 units, it's on the midline. Okay, so this is the whole point of something being periodic, is being able to spot patterns, repeat those patterns, and figure out what they mean for what the function looks like. All right, and then in between those points, you go high point, low point, high point, and then reverse it. So going backwards, it'd be low point, high point, low point, high point, and low point. All right, so you see this looks like a zigzag pattern. Try your best to sort of make all of these graphs like a little bit more rounded, so not as zigzaggy, but just slow rolling shapes like that. All right, so that is our sine curve for this one. Next one is a tangent. So the amplitude is always undefined no matter what tangent line you're graphing. The period, you start with pi, and it's pi divided by whatever's in front of the theta. So pi divided by 1, which is pi. There is a phase shift here. This is a phase shift when you see it in parentheses like this. You are moving pi over 4 units, and the theta minus pi over 4 means it is pi over 4 units to the right. So you're going to shift everything visually to the right just a little bit. Vertical shift would be if you had a free-floating constant not attached to anything like that one. And since you don't, you have no vertical shift, which means the midline just stays right at y equals 0. Okay, so there's no up or down shift at all happening with this graph. So this time, remember your tangent graph initially starts at the origin. Well, you're going to shift everything over pi over 4 units. All right, so now our initial main cycle is going to start right there. And it used to have, so without any sort of period change, it used to have an x-intercept every pi units. So it's still going to happen every pi units, but that shift is going to happen moving it over to the right. Okay, so it would normally be like at 0, but we shifted it over. It would normally be at pi, but we shifted over. Then at 2 pi, but we shifted over. Okay, so let's reverse back. Negative pi, but we shift it. And 2 pi, negative 2 pi, but we shift it. Okay, so you can see that shift happening. You can see they're still equally spaced. They are all still spaced pi units apart. They just all literally shifted 1 grid to the right. All right, so that's what our shift is going to look like. And then your asymptotes are going to shift the exact same way. So your asymptotes are halfway in between the x-intercepts, but notice those are going to be shifted as well. So normally you would have it at pi over 2. It now shifts over here to 3 pi over 4. So it's going pi over 4 units to the right as well. But we figure out patterns, and we notice that the pattern is it's always halfway in between the x-intercepts. Okay, so we see that pattern. One last little detail we want to keep in mind. Your tangent graph goes from the lower left to the upper right. And these in-between spots right here, between the asymptotes and the intercepts, normally it goes down a full unit. Here, it's only going down half a unit. So half a unit in each spot right here, and then just repeat that pattern between every set of vertical asymptotes. That way it keeps it a little bit of a compression. Okay, so just connect the dots right here using those vertical asymptotes and the points you plotted to guide you. And then we run out of space on this last one, so we'll just show that piece. All right, and then number 9, we've got a little bit of everything. This one's a cosine graph. So the amplitude is the number in front of cosine. The period, you do 2 pi divided by 1/2. So 2 pi times 2 ends up being a 4 pi. So this one's going to be really wide. The phase shift, that's what you have in parentheses here. So we are going pi units, and it is theta plus pi. So we are going pi units to the left. And then this free-floating number right here is the vertical shift. We are going 3 units, and since it's subtraction, that would be 3 units down. So that is going to change our midline from 0 down to -3. All right, so I like to start by getting a visual on my midline. And then it's also not a bad idea to kind of focus on where my period, my one cycle, is going to be starting now. So everything is moving pi units over to the left. So this is kind of our starting axis rather than the y-axis. So it starts somewhere at this value. Okay, so remember, cosine cycles start up at their high point. So the high point would be 2 units off the midline. So this cycle is going to start right there. Okay, so we've got that part. Then we know the cycle is going to end 4 pi units later. All right, so 4 pi units later, if I go over 4 pi units, it actually takes me off the graph. It would take me all the way to 3 pi. So think of the way that these shifts are going to work. So 4 pi means that every pi units, I have one of my major points. So here's the high point. Pi units later, I would have the midpoint. Pi units later, I would have a low point, which is 2 units down from the midline. Pi units later, I have another midpoint. So here, this is only 3/4 of my cycle. This is point 1, 2, 3, and 4. But then I run out of space for point 5. It would be over here. So I can just reverse it, and I can go back. So if this is point 1 of this cycle, it's also point 5 of the previous cycle. So I can reverse back and do point 4 of the previous cycle. So we just go through here, and you can see actually that shift makes it look like a sine graph. Sine and cosine graphs are all just shifts of each other.